All right. Before we talk about adding and subtracting rational expressions, we need to look at something called the least common multiple, or LCM for short. All right. Here's a definition. The smallest multiple that two or more numbers have in common is called the least common multiple of the numbers. Okay? So let's look at a concrete example. Here we're asked to find the least common multiple of 4 and 5. All right? To find that, we're going to make two lists of all the multiples of 4 and all the multiples of 5. All right? Well, not all of them, right? Because they go on to infinity. But here are some of them. Here are some of the multiples of these numbers. All right, we have 4 times 1 times 2 times 3 times 4 times 5 and times 6 times 7 times 8 on and on to infinity. All right, and same thing with 5. Right, this is 5 times 1 times 2 times 3 times 4 times 5 and on and on. All right, so we have our lists and we're looking for the least common multiple. Okay, so it's common to both lists and it's the least. All right, so we're looking for the smallest number that occurs in both lists. All right, in this case, the number is 20. All right, so my LCM is 20. And notice that 20 is actually the product of 4 and 5. All right, it turns out that if the two numbers don't have any common factors, the LCM is just going to be their product. All right, but it doesn't always work out that way. Okay, let's look at a different example. Here we're asked to find the LCM of 4 and 6. All right, and 4 and 6 have a common factor of 2. All right, so their LCM is not going to be their product. All right, it's going to be something less than that. All right, so notice that their product is 24, and 24 does appear in both lists, right? But that's not the smallest number. All right, the smallest number is 12. All right, it appears in both lists. Okay, so the LCM of 4 and 6 is 12. All right. So next, let's talk about the least common denominator, or LCD for short. All right. The definition is simple. All right. Given two or more fractions, the least common denominator is the least common multiple of the numbers in the denominators. All right. So it's simply the smallest multiple that the denominators have in common. Okay. So here we're asked to find the LCD of 4 and 6, then add the fractions, all right? So we need a common denominator to add those fractions, and that denominator is going to be the LCD, all right? So we already found on a previous screen that the least common multiple of 4 and 6 is 12, all right? So that's my LCD, okay? So we need to get a common denominator of 12. All right, so let's try to do that right now. All right, we're adding 3/4 and 5/6. Their LCD is 12, so we need to get a common denominator of 12. All right, so what we're going to do is just take 4 and multiply it by 3 to get 12, right? Get what we want here. And then take 6 and multiply it by 2 and get what we want here. All right. Then that gives us 3 over 12 plus 5 over 12. And 3 plus 5 is 8, so we get 8 over 12. All right. So I've made a mistake somewhere. All right. I'd like you to pause the video and ask yourself, what's the mistake? All right, where is it? The mistake is right here. Okay, this step right here. I need a 12 in both denominators, right? So I simply multiply each number by whatever you need to get to 12. All right, but I can't do that. Right, because when I do that, I'm changing the entire problem, right? I'm working on an entirely different problem now than what I started with, all right? So I can't just multiply the denominators like this, all right? What I need to do instead is make the denominators equal to 12, all right, without changing the original problem, all right? So to do that, what we're going to do is multiply each fraction by something equal to 1, all right, so as to not change it, all right? I know that 4 times 3 is 12, all right? So I need 3 down here, but I can't just put a times 3 down here, right? I have to include this 3 up top as well, okay? Both of these fractions in blue are just equal to 1, All right, anything multiplied by 1 is just itself. All right, so we're not changing the original problem. We're just shifting the format of how we look at it, all right, to get two new fractions to add. All right, so when we do these multiplications, right, we get 9 over 12, okay, and we get 10 over 12. So notice that 3/4 is the same thing as 9/12, and 5/6 is the same thing as 10/12. All right, so we got a common denominator, and we didn't change the original problem. All right, so this is great. Now we can add the fractions like this, right? Two fractions condense into one, right, with that common denominator, and we just add the stuff in the numerators. All right, 9 plus 10 is 19. So our final solution is 19 over 12. All right, this is how we add fractions. We have to get a common denominator, and we have to do it in a legal way, right, without changing the original problem. All right, let's try one more just to make sure that we've got a handle on the LCD and the common denominators. All right, so here we're asked to add 2/3 plus 5/7. All right, the LCD is 21. All right, 3 and 7 don't have any common factors, so their least common multiple is simply their product. All right, so we need a 21 down here and a 21 down here. How do we do that? Multiply each fraction by something equal to 1. All right, to get from 3 to 21, right, I need a 7. All right, so we're going to choose 7 over 7 here. All right, and to get from 7 to 21, we need a 3. So we'll do 3 over 3 here. And when we do this multiplication, here's what we end up with, right? This is two multiplication problems here. All right. And then, since the denominators are the same, we condense this fraction into 1, and we add the stuff in the numerators. All right, we get 29 over 21. So that's our final answer. All right. So now we're finally ready to talk about adding rational expressions. All right. So let's give it a shot. Here I have 5 over x plus 6 over y. Okay. X and y are variables. Okay. I don't know if they have any common factors. All right. So I'm looking for the LCM of x and y. All right. So I'm going to assume that they don't have any common factors. All right. And simply take their product as my LCD. Okay. So the least common multiple of x and y is xy, the product xy. All right. And it turns out that whenever we're trying to find the LCD of rational expressions, what we do is we factor the expressions and we multiply the distinct factors in the denominators. All right. Here, we don't need to factor these, right? So we kind of skip over that and we just move to multiplying the distinct factors in the denominators. All right, so we have x and y, just multiply them together to get xy. That's the common denominator we're looking for. Okay? So let's do that. All right, we need xy down here and we need xy down here. Okay? So we choose y over y to multiply here, and we choose x over x to multiply here. Right? That'll give us the common denominators. Okay? So this product is 5y over xy, and this product is 6x over xy. All right? Yx is the same as xy by the commutative property. All right, so now we have the same denominator, so we can add the stuff in the numerators. All right, we get 5y plus 6x up top. So this is my final answer. All right. So we're getting a common denominator exactly the same way from when we just had numerical fractions. All right. We take the LCD to be the product of the distinct factors. All right, let's try another one. Here we have 2 over this plus 3 over this. All right. So the question is, what's the LCD? All right, what is the least common multiple of this and this? All right, remember what the rule says to do. All right, let's bring that back. To find the LCD of rational expressions, we factor the expressions and multiply the distinct factors in the denominators. All right, so notice that x plus 4 appears here twice. All right, So when we multiply our factors, we're just going to include it once, all right, because it's a distinct factor of x plus 4, all right? So we have x plus 4 and x plus 3 and x plus 5, right? Those are our three distinct factors, all right? So we're going to multiply them together and call that our LCD, all right? So just like before, we're going to multiply these fractions by something equal to 1, okay? X plus 3 times x plus 4, what's missing to get to this? The answer is x plus 5, right? So we multiply the top and the bottom by x plus 5, okay? And then here, x plus 4 times x plus 5, all right, times what equals this? All right, the answer is x plus 3, okay? So when we perform these multiplications, all right, this is what we get, okay? Let's take this to the top of the screen, okay? I have my common denominator, right? So when I add these fractions, I can condense them into one, right? And just add the stuff up top. All right, so I get 2x plus 5 plus 3 times x plus 3. All right. When I distribute, I get 2x plus 10 plus 3x plus 9. Okay? So now I notice that I have some like terms going on, right? 2x and 3x, right? We can add those together to get 5x in blue here. And 10 plus 9, right? That's 19 in red. Okay? So 5x plus 19 over this big common denominator is my final answer. All right? Let's try another one. All right, here we're asked to add 3 over this plus 5 over this. Okay, so what's the first thing we need to do? We need to factor the rational expressions, all right, to see what we're dealing with. Okay, x squared minus 1, that's the difference of squares, right? So we can factor it like this. And then this trinomial, right, we can go through trial and error to get this. Okay? So what are the distinct factors in the denominators? All right, x plus 1 appears twice, all right, so x plus 1 is a distinct factor. And then we have x minus 1 and x plus 2. All right, so we're going to multiply those three things together. All right, that's our LCD. Okay? So we're going to multiply each of these fractions by something equal to 1. Okay? So as to not change the problem. All right? And next we're going to take this big thing to the top of the screen. Okay? So when I multiply this times this, I get 3 times x plus 2 over the common denominator. And then here, when I multiply this by this, I get 5 times x minus 1 over the common denominator. All right, so we're finally ready to condense these fractions into one. Okay? And this is what we have. All right, let's take this to the top of the screen. All right. When we distribute, we get 3x plus 6 plus 5x minus 5. Okay? And we see that we have some like terms here, right? 3x and 5x, we can add those together to get 8x in blue. All right? And 6 minus 5 in red is 1. Okay? So we have 8x plus 1 over this big common denominator, right? That's our final answer. All right? Next, let's move to subtracting rational expressions. All right? This is a little bit harder to do, but we can handle it. All right? Here, we have 3 over this minus 2 over this. All right? The first step, once again, is to factor the rational expressions. All right? These trinomials are both factorable. Okay? So we get this minus this. All right? Then we ask ourselves, what are the distinct factors going on in these denominators? What are the distinct factors? There's 3 of them, right? X plus 3, it appears twice, so we'll just include it here once. And then x plus 2 and x plus 4. All right, so we multiply those together to get the LCD. All right. So next, just like before, we multiply each of these fractions by something equal to 1. All right, to get this LCD, right? Get this common denominator. All right, let's take this to the top of the screen. All right, multiply these two fractions together and you get this. And then we're subtracting this product here, right? This product will give you this. Okay? So watch closely what happens next. All right, fasten your seatbelts. This is going to get a little messy. All right, we have our common denominator, right? So we can condense these into one and do 3 times x plus 2 minus 2 times x plus 4. Okay? So when we distribute, we get this. All right, but this is incorrect. All right, there's a mistake somewhere. All right, pause the video and see if you can find it. All right, the mistake comes from the fact that we're subtracting this entire thing. All right, we're subtracting 2 times x plus 4. Okay, so there's a sign error, right? This is incorrect down here. Right? This should actually be a minus 8. All right, so this is really confusing at first, right? So we want to go back to this step here, right, and try this again, but do the subtraction in a smarter way, right? There's a smarter way to do this, all right? This minus this, what we're doing calls for some brackets, right? We're going to use brackets here. 3 times x plus 2 minus this whole thing, all right? So we're putting it in brackets to emphasize that, okay? So when we distribute, right, we get 3x plus 6, okay, minus, in brackets, right, this is 2x plus 8, okay? So let's take this to the top of the screen and remove these brackets, all right? 3x plus 6 minus this whole thing, all right? What we need to do is distribute the minus sign to the 2x and to the 8, right, to get minus 2x minus 8. All right. So this is correct now. There's no sign error. All right. We have some like terms here. So we have 3x minus 2x. That gives us x in blue. And we have 6 minus 8. That gives us negative 2 in red. All right. So this is my final answer. All right. That does it for this video. Thank you for watching, and like and subscribe.